Hi, my name is Trevor Albertus. Welcome to the NXP SSL Design Center training video. Today I will be demonstrating some of the features and functionality that is offered in NXP's solid-state lighting online design center. There are a few different ways to access these tools. I'm going to go ahead and enter through the Arrow homepage by selecting the electronic components, online design solutions. This brings us to the Design Web Transom homepage. This is where you can access all of Transom's tools. We're going to choose Applications, Lighting, SSL, the solid state applications, and select the NXP tool. First step in the tool is to enter or edit some design parameters such as the LED type, the forward voltage, impedance, current, and number of LEDs in series or in parallel. If you notice, there is a list of some important calculated values such as the output voltage and current and power calculated values down here on the bottom. The user also has the option to specify their dimming capability as well as some more advanced inputs. Once finished, go ahead and select Continue. The next step in the design process will be to select a transformer from the transformer table. I'm going to go ahead and choose the E13 core size. Next, the user will need to select the flyback controller. The main decision here is whether you want an internal or external switch for the IC. I'm going to go ahead and go with the SSL 2101, which features an integrated switch. At this point in the tool, the user will be required to log in by providing their username and password. If you do not have an account, you'll be required to register before moving any further in the tool. We'll go ahead and log in, providing my email address and password. And this brings me to the designed application schematic. Here the user would have the option to edit component values. Also, if you select the dimmer button, this will take us to the more advanced dimmer settings. Here the user has the option to edit a few different settings and see how it is affecting the dimming curve. For example, if I change my frequency reduction to 10%, the graph should update with my new value. If I select Apply Changes, I will redesign my application schematic now using my new settings. And that gives me my new app circuit. You can also access the bill of materials. This gives me a list of all the components in the schematic. You can select a distributor, if preferred. This gives me a list of parts actually available from DigiKey. Each of the components will have set applied filters to them, such as capacitance, type, voltage rating, tolerance, package. If you notice up here, there is also numerous options such as manufacturer, temperature coefficient, and so on. These filters can be cleared by selecting the Clear All button, which will then give you a list of all capacitors. Next tab in the tool provides a design summary. This includes an overview of my design inputs, advanced parameters, parts list, power loss pie chart, as well as my dimming curve, and schematic image. If you notice at the top of this page, there are several links for data sheets, app notes, PDF summary, as well as other features available. Once I'm finished with my design, I have the ability to save for future reference. Select the My Designs tab. Just simply give the design a name and maybe a description. Select Save. The last topic I want to bring up is the feedback button. There should be a feedback button located in every one of Transim's tools. We'd love to hear from you on how to improve these tools. Please use the feedback button and let us know your thoughts. Thank you. My name is Trevor Albertus. Welcome to the NXP CFL Design Center training video. Today I will be demonstrating some of the features and functionality that is offered in NXP's compact fluorescent lighting online design center. There are a few different ways to access this tool. I'm going to enter through the Arrow homepage, arrow.com. As you see here, select the electronic components link. Then over here on the right, there's an online design solutions link. This takes us to the Transim Design web, where you'll have access to all of Transim's design centers. Go ahead and select Applications, Lighting, and CFL. NXP CFL, and go ahead and start the tool. So here the user has the option to use the single 230 volt RMS 50 Hz design, or you can choose to do a user-defined design, which will give you the option to customize the line voltage as well as the frequency. So if I select user-defined, I can then specify my voltage and frequency. There's also a boost feature available for selection here. If you notice, there is a quick help menu down here at the bottom of the page, which gives some helpful hints when using this design tool. I'm going to go ahead and stick with the 230 volt design. Select Next. This takes me to the burner page, where you have the option to edit some parameters such as the nominal voltage and current, as well as the filament resistance. If you notice, there's also an Advanced tab here, which enables numerous other parameters such as ignition, preheat, filament materials, and an extended burner model, which can be customized as well. When you have the design values you want to use, go ahead and select Next. The next step in the design process is to select the input burner values. Here you have the option to adjust the input capacitor as well as the fuse resistor values. You can also see the effects of your changes and how it is impacting the buffer parameters such as the peak, average, and RMS voltages, as well as some power and currents. There's also efficiency and cutoff frequency under the advanced section here. Go ahead and select next. Moving on in the tool, the next step is to define the resonant tank by setting the operating frequency. The tank values will be calculated based on this frequency input. There is also a resonant coil series resistance parameter available under the advanced menu. Next, we can select the IC and package and view important calculated current and thermal values. So you have the available ICs here, as well as packages. For example, you can change the temperature value and see how it affects the power loss. Whenever you change values, make sure to select the Apply button. That should adjust the calculations as well as the graphs on the right-hand side. Next step in the tool shows the effect of the RMS control. This top graph shows the average burner power versus the average DC bus voltage. And the bottom graph shows the half bridge and burner current versus the average DC bus voltage. At this point in the tool, the user will be required to log in by providing their username and password. If you do not have an account, you will be required to register before moving any further in the tool. So I'll go ahead and log in here, since I do have an account. Once logged in, I will be taken to the schematic page, which is showcasing the IC in the application circuit. So once I have finished my design, I may want to save this for future reference. At any point in the tool, I can save my current status by using the My Designs menu. Simply select Save and give the design a name. That's it. I also have the option to share my design with other users. I can send an invite to a specific user by selecting the Share button and providing an email. The user will receive a notification email in which they will be able to then access that design. If they do not have an account with the tool, they will need to register before accessing that design. There are also a couple of menus available containing some key results such as the schematic, graphs, and bill of materials. If I select the graphs, I then have all the available graphs which were showcased in the previous design steps. The parts list. This shows the basically the bill of materials. It gives me a list of all the components in the schematic, and I also have the option to choose a distributor, such as Arrow. Which then gives me some pricing and the option to order parts directly from Arrow. If I select the part number link, this should take me to the distributor part page. If I select the Find icon, as you notice, there are some applied filters here, such as this specific component is using capacitance, voltage rating, tolerance, and packaging for the filter criteria. I also have the option to edit numerous other filter criteria up here on the top. If I want to clear my filters, just select the Clear All button. And this gives me all available parts. You also have the Design Overview option. The Design Overview section, basically a summary of my design. Shows all the previous graphs, as well as my design inputs, schematic image, and BOM. The last topic I want to bring up is the feedback button. There should be a feedback button located in all of Transim's tools. We would love to hear from you on how to improve these tools. Please use the feedback button and let us know your thoughts. Thank you. Hi, my name is Trevor Albertus. Welcome to the NXP HFTL Design Center training video. Today I will be demonstrating some of the features and functionality that is offered in the NXP's high-frequency tube lighting online design center. There are a few different ways to access these tools. I'm going to enter through the Arrow homepage, arrow.com. Select the Electronic Components link, and then select the Online Design Solutions link. This brings us to the Transim's Design Web homepage. This is where you can access all of Transim's design centers. Select Applications, Lighting, CFL, and NXP HFTL. Now the first step in this tool is to provide some key requirements, such as do you want to use the dimming feature, which lamp type, and filament heating. Currently, the only part available is the UBA 2014, as you can see here. If you notice, there is also a quick help menu at the bottom of the page, which gives some useful, helpful hints when using this design tool. There's also an application status indicator to make sure your choices are valid. When you have your selections, go ahead and select Next. Here you can set the external DC bus voltage. I'm going to go ahead and keep the 400 volt default value. The next step in the design process is to define the lamp parameters. The nominal lamp current and preheat time may be modified. The nominal lamp voltage and nominal power are calculated based on the given lamp current and lamp curve. If you notice, there's an Advanced tab available with design inputs for the more advanced users. For example, you can define your own lamp model or edit the filament heating specs. Be sure to select the Apply button if any changes are made. Moving on in the tool, the next step is to define the resonant tank by setting the operating frequency. The tank values will be calculated based on this frequency input. There is also LC combinations available under the Advanced menu. Select Next. Next, you can view some calculated RMS currents, coil peak current, and MOSFET properties. You also have the option to edit the RDS(on) value of the FET and see how it is affecting the conductive loss. Select Apply. And next. This brings me to the schematic page, which is showcasing the IC in the application circuit, and the user can view the calculated component values. Once I have finished with my design, I may want to save this for future reference. At any point in the tool, I can save my current status using the My Designs menu. Simply select Save, give the design a name. Select Save. I also have the option to share my design with other users. I can send an invite to a specific user by selecting the Share button and providing an email address. Once a design has been shared, the user that you shared with should receive a notification email. He or she must be registered with the tool in order to access the design. There are also a couple of menus available containing some key results, such as the schematic, graphs, and parts list. As you can see here, I can access all the graphs that were produced in the previous design steps. The parts list is basically bill of materials with the option of selecting a distributor, such as Arrow. This will give us the option to view some of the Arrow prices, as well as order the parts directly from their website. Selecting the part number should bring us to the distributor's part page. Also, if you select the Find icon, you'll notice there's numerous applied filters that are being used for this specific component, such as the packaging, tolerance, capacitance, voltage rating. You also have the option to add or edit any of the filter criteria located on top here. If you want to clear your filters, simply select the Clear All button, and this will give us all available capacitors. There's also a design overview option available. If I select Show, this should give me basically a summary of my current design, showing the design inputs I've used, as well as some of the graphs that were created, my schematic image, and my finalized BOM. The last topic I want to bring up is the feedback button. There should be a feedback button located in every one of Transm's tools. We would love to hear from you on how to improve these tools. Please use the feedback button and let us know your thoughts. Thank you.